Now that we know how to calculate a formula mass, we can do some more conversions of various types. But let's start again with just an element, copper. And my holy trinity for copper is the fact that 1 mole of copper equals Avogadro's number. And since copper is an atom, we'll say of atoms copper. And it also equals the gram formula mass. And since the atomic mass of copper is 63.5, this would all equal that many grams of copper. Now I like to start problems by our factor label method with the answer that I'm looking for, and I'm asked for a mass of copper. And of course this is a mass of copper right here. So I'll start with 63.5 grams of copper, but I have to use that in combination with either moles of copper or atoms of copper. And because I'm given protons, I'm looking ahead to the fact that I know a relationship between protons and copper. The periodic table tells me there are 29 protons per 1 copper atom of copper. So if I want a mass of copper and I associate it with a number of atoms of copper, I'll be able to get my answer. And this is why. If there are 63.5 grams of copper per Avogadro's number of copper atoms, I have my mass of copper and I can cancel atoms of copper, because with this relationship I have atoms of copper. 1 atom of copper is the equivalent of 29 protons. And of course this cancels atoms of copper and substitutes protons, but since I was given protons in the question, I can now make the final cancellation. There are 2.5 times 10 to the 25th protons in the sample, and protons will cancel protons, leaving me with a mass in grams of copper. And when I take my calculator and I multiply all of this, and this measure number has 2 significant digits, 3 here and 3 there. This is an exact number. You can't have part of a proton. So I want 2 digits in my answer based on that value, and it rounds off to 91 grams of copper would contain all those protons. Now, as a second example of a problem we can do, how many water molecules are in 26-gram sample of water? Well, first of all, I might want to remind myself of the formula of water. It's H2O, dihydrogen monoxide. And that means it has a formula mass that contains 2 hydrogen atoms at 1 atomic mass units each. And it has 1 oxygen atom at 16 atomic mass units. So water has a total combined molecular mass, because it is a molecule, of 18 atomic mass units. Now that's important so that when I write my holy trinity for water, I know 1 mole of water molecules equals Avogadro's number of molecules, which I abbreviate MC for molecules of water. And that has to equal the gram formula mass, which of course is a molecular mass in this case. So it equals 18 grams of water. But the trinity is always true. 1 mole of whatever you're talking about equals Avogadro's number of whatever you're talking about. We're talking about molecules in this case. And it also equals the gram formula mass. And the formula mass of a molecule is called a molecular mass, but still its gram formula mass is the same number, but written in grams. Now, to answer the question, I want to know how many water molecules are there. And I'm staring at the answer right there. There are Avogadro's number of water molecules per either 1 mole of water or 18 grams of water. And I choose the 18 grams, the gram formula mass of the water, because I was given a mass of water in the problem, and I know I'm going to have to cancel it to be left with my answer. So the only thing that cancels the mass of water in grams is this mass of water I was given in grams. And when I multiply out, I'll be left with a number of water molecules. And with 3 digits, I get 8.70 times 10 to the 23rd molecules of water. That's a whole lot of water. Now, as a further example, how about this problem? How many formula units are there in 25 grams of sodium chloride? Well, I remind myself that sodium is a +1 cation, chloride is a -1 anion, so the formula of sodium chloride has a 1-to-1 ratio. And of course, we can't call this a molecule because it's an ionic compound, so we call it a formula unit. And we want to know, it's the ionic equivalent of a molecule if we were talking about a molecular compound. So we want to know how many formula units there are. Well, first of all, we should calculate the formula mass. We're probably going to need it. There are 23.0 atomic mass units, equivalent to 1 sodium atom, and 1 chlorine atom is 35.5 atomic mass units. That's a grand total of 58.5 atomic mass units. Why do we need to know that? Because anytime we make mass mole conversions, or particles, or formula units, whatever you want to convert to, you need to know your Holy Trinity. And in this case, 1 mole of sodium chloride is the equivalent of 6.02 times 10 to the 23rd formula units, and I'll abbreviate that FU of sodium chloride. And it also equals the gram formula mass of sodium chloride. So now, to start the problem, I ask how many formula units are there? Well, there's my answer right there. There's 6.02 times 10 to the 23rd of these formula units per either 1 mole or per 58.5 grams. And looking ahead, since I was given a mass, I'm going to choose this ratio, 58.5 grams of sodium chloride. And I'm done in one step to find formula units because all I need to do is cancel the mass of sodium chloride. And given this mass of sodium chloride, it easily cancels. And it gives me 2.57 times 10 to the 23rd formula units sodium chloride. Jumping ahead to the last example, I want to know how many atoms of hydrogen there are in 5.8 grams of propane. First, I remind myself that pro means 3 carbons and ane means 2 more than twice as many hydrogen atoms. And I need to know that to calculate the formula mass of propane, which is 3 carbon atoms at 12 atomic mass units each is 36 atomic mass units. 8 hydrogens at 1 atomic mass unit each is 8. So the formula mass of propane is 44 atomic mass units, meaning that 1 mole of propane is equal to Avogadro's number of, in this case, molecules, because this is a molecular compound, propane, and it also equals the gram formula mass of propane. So I'm going to start with the answer. How many hydrogen atoms are there? Now, I look at the formula and I know that there are 8 hydrogen atoms in 1 molecule. So I'll remind myself of that. There are 8 atoms, hydrogen, in 1 molecule of propane. So if I want to start with the answer, I'm going to start with this ratio right here. It has my answer. 8 atoms of hydrogen per 1 molecule propane, C3H8. So I have my answer if I can cancel molecules of propane. Well, Avogadro's number is associated with molecules of propane. But I have to use it with either a mass of propane or moles of propane. And since I'm given a mass, I choose mass of propane in my ratio. This allows me to cancel molecules and replace it with mass, and I'll have my answer left over if I cancel the mass of propane, which is why I was given the mass of propane in the question. Everything cancels except atoms of propane, leaving me 6.3 times 10 to the 23 atoms of hydrogen.